so much for joining us today. My name is Ashley Sullivan, and I work with the marketing team here at Wolf & Company. I'll be your host for today's webinar on Virtualization and Cloud Computing 101. Before I introduce today's presenter, I'd like to go over some general information. Today's presentation will last about 45 minutes, and the slides can be downloaded at www.wolfandco.com/webinars/2012. We'll have time for questions at the end of the webinar, so if you have any questions at any point throughout the presentation, please send them in to me using the questions box located on the control panel on the right-hand side of your screen. You have two options for audio today. You may dial in by phone or listen through your computer. If you need to communicate with me at any point during the webinar, please use the chat box located on the webinar's control panel, as our audience will be muted throughout the presentation. I'd now like to give a brief background of the firm. Wolf & Company was established in 1911, and we are very excited to have just celebrated our 100th anniversary. Building on our tradition of unparalleled guidance, we provide our clients with assurance, tax, business consulting, and risk management services. We have over 180 professionals working for the firm and have offices located in Boston and Springfield, Massachusetts, and Albany, New York. We currently employ over 45 risk management professionals in the areas of IT assurance, internal audit, regulatory compliance, and Wolfpack integrated risk management, and provide services to over 200 financial institutions in 19 different states and 1 U.S. territory. I'd now like to introduce today's presenter, Ryan Rodriguez, a supervisor in our IT Assurance Services Group. Thanks so much for presenting today, Ryan, and I'll now hand the presentation over to you.
Right. Thanks, Ashley, and thanks everyone for joining us today. Today's presentation is Virtualization and Cloud Computing 101. So what do we intend to cover today? First of all, we want to go over the basics of what is virtualization and what is cloud computing. I know we have a lot of network administrators and engineers on the line, but there's also a wide variety of job responsibilities and functions. So we will cover the basics of, you probably heard the terms, but how do they work? And more importantly, what does it entail for your own IT environment? Once we've covered that, we'll also talk about the benefits of each technology and the risks associated with each technology, because they do introduce new risks to your environment. And finally, probably most importantly, and why most of you are here, security and control considerations that can be applied to each of these technologies in order to mitigate the risks. So we'll start with virtualization. In order to understand what virtualization is, it's first important to understand what a traditional configuration would look like in your data center. So typically, traditionally, an organization would have many servers. And when I say server, I mean a physical box that sits on a rack. And that box has hardware. It has the chassis. It has a CPU. It has a hard disk inside it, an operating system that works on it. It has network adapters and other hardware and other operating systems that are all associated with every individual box. All of that hardware and processing power can't really be shared with the other servers that exist in your environment. So each server is an island unto itself, essentially. And you need to have a high number of servers for various reasons. Sometimes you want one to be segregated from the other areas. Sometimes you want different types of software to exist on a server. Sometimes you just need more disk space, so there's a number of file servers as opposed to one. What this means is that the number of servers tends to step up very quickly within an organization. You can start with 5, but that can quickly grow to 10, to 20, and to 200. And as the number of servers increases, it becomes exponentially more difficult to actually maintain all of them. Because each of them are going to have support contracts, software to maintain, and firmware to maintain. And also, there's a few other benefits to be realized by virtualization. So what are those benefits? What do we actually do? As I mentioned, each server in a traditional environment can't share its resources with others. So you need to spec it out to account for peak utilization. That means when everyone shows up to work in the morning, they're going to use the internet at the same time to check their email or their website. Usage is going to spike, and you need to account for that, but then the usage is going to drop way down. Certain applications are only used at certain times of the day or certain times of the month. And at those times, the application servers might be very busy, but through the rest of the month, they won't be very busy at all. So during non-peak usage, a lot of those hardware resources are wasted. And a major part of the reason that virtualization was conceived was to pool resources to use them more efficiently. The technical term here is called infrastructure convergence. It allows you to take all of those hardware specs and serve them out wherever they need to go at any given point in time. How do you do that? Well, with virtualization, you take every individual physical server, all of the hardware and all of the components and the firmware that are associated with them, and you replace them with virtual servers. A virtual server is essentially just a data file, a configuration parameter. So you can take any number of those virtual servers, from 1 to 100 or more, and load them onto one single physical host server. So this is going to be one exceptionally powerful server that hosts a number of virtual server files. What that allows you to do is the host server has its own hardware that gets, as I mentioned, it gets served out where that hardware needs to be at any given point in time. You can almost think of it as when old factories used to have their own power plants on site. When the electricity grid came about, the power went where it needed to be, rather than every single individual site needing to supply its own. That's what we're dealing with virtualization. And just to illustrate that, this is the example that I showed you before, a small system with just a handful of servers. But what we do is we take each of those servers, we virtualize it, turn it into a file instead. File servers, app servers, database servers. And then those files get loaded onto a pair of big host servers. Each of those host servers has a more powerful version of processing and larger hard drives, but still just one operating system and the associated hardware components and firmware that go with it. So that's the very brief overview of what virtualization is. Many of you probably already saw that, but we're going to get in now a little bit more detail about why we do that, some benefits that can be realized, and the risks that we need to be concerned with when we do that. So the quick recap, the components that we're going to be talking about here, the host server, which as I mentioned, those are the large, powerful servers that actually store the data. That's what's left of your physical environment. Typically, those operate on either a Linux ESX platform or a Windows Server 2008 platform. And they do have their own operating systems, in addition to the virtual servers that run on them. Next, we're going to be talking about the virtual server application. This is an application that is installed on the host server, and it provides the interface between all of the virtual servers and the host server and the rest of the world. Now, that server, or that server application, is going to make it appear that the virtual servers can still operate as if they were a traditional physical server. To most of the outside world, those virtual servers will appear indistinguishable from a real server, quote-unquote real server. That's a process called hypervisor. So the system like VMware or Hyper-V is called a hypervisor, and it's that portal between the virtual server and the real world, I suppose. So those are the three areas that we're going to be dealing with. What are the benefits of this type of system? Well, first of all, fewer physical servers to manage. That almost goes without saying. But that's a huge benefit for many reasons. Having less hardware means that you have fewer individual servers to manage independent of each other. If you have 100 servers, they could have been purchased at different times and have different contract expirations. They could have different hardware specifications, different serial numbers and product numbers to track. It's a lot of administrative overhead just to track and maintain all of those individual servers. So reducing those to just a few servers, just a small fraction of them, makes it much easier on your IT team to actually manage these. In addition, the hardware itself gets served out more efficiently, as I've mentioned a few times, so you need less total hardware. You can save money on the the total amount of memory that needs to exist in the environment, things of that nature. Also, when you're dealing with fewer individual servers, there tends to be less risk of hardware incompatibility and other types of malfunction that can result from disparate hardware specifications. Another key benefit to virtualization is the easy management of the virtual server files. I use the term easy. I should probably say relatively easy, as most things in IT are, relative to managing physical servers. Virtual server files can be saved and copied just as any other file, like a Word file, could be on a hard disk. And as long as it's linked to that hypervisor application, then you essentially have the server that can be copied and restored almost as easily as you can do with any other file. So obviously that makes backup and restoration easy. It makes storage and portability of the servers much easier. For example, at a disaster site, it's much easier to copy a file to a disaster recovery facility than it would be to lug an entire physical server over there. You can even duplicate servers for things like testing purposes. Disaster recovery and business continuity has become a huge benefit with virtualization, particularly with some of the newer technologies that are emerging surrounding virtualization technology. So you can cluster virtual servers. When one fails, it fails over to the other server, as you could do with other servers, but it's a little bit easier with some of the applications that wrap around VMware or Hyper-V. You can copy virtual servers, as I mentioned, to have them available for backup and restoration purposes in an emergency. If you traditionally had just a warm site with hardware ready to go, it makes it much easier to turn that into a hot site or near hot site that you can fail over to very quickly in a matter of minutes rather than hours. Test environments are easier to do when you have a virtualized environment. You can easily create and delete a test server, mess around with it all you want, and blow it away when you're done. When you're doing that, you can mirror the production environment without having any negative impact on it. So if you want to work with real data, if it's not data that's too sensitive to test on, you can mirror an existing database server, try out your patches on it, try out your updates and revisions on it, your software versions, make sure that everything works, and then when you're done, delete the test server, roll it out into the real environment. A lot of the new hardware that's coming out, particularly multi-core processors, are used more efficiently in a virtualized environment than they would be in a traditional environment with just physical servers. And lastly, this situation is very highly scalable. It tends to scale up better than it scales down, because if you're only virtualizing 4 servers, then there's not many efficiencies to be realized there. But as I mentioned, you can easily grow into hundreds of servers in your environment. It becomes exponentially more difficult to manage all those servers. With a virtualization infrastructure in place, that becomes much, much more easy. And you can scale upwards very quickly and very relatively easily. So there's a lot of powerful benefits involved with virtualization, but obviously there are risks too. Most of the risks concerning virtualization surrounds those host servers themselves. If one of those host servers is compromised, then all of the virtual servers that exist on it could be at risk as well. And when I say compromise, we're talking about the security triad. So it's confidentiality, but it's also availability and integrity. If a host server is completely corrupted, you have a big problem. If a host server is taken offline, physically destroyed, again, you have a big problem. All of the virtual servers that existed on it could be impacted in any of those situations. And it also applies to security and confidentiality as well. Reduced hardware fault tolerance falls under that same vein of availability. If something were to happen to a network interface card on a virtual server, would all of your other servers that exist on the virtual servers, would those be impacted because of the one piece of hardware that failed? And lastly, if you're using an ESX environment, which is the most common that we see, those are Linux servers, and many places don't have a high degree of Linux expertise in-house, at least not relative to a Windows environment. So if that's something where you've traditionally been a Windows environment and you're just getting this one ESX box to manage, you may not have all of the in-house technical expertise in order to manage that effectively. And there are some issues that can arise from that. So to move on now, we want to talk about the security and the controls that we should put in place. We're going to step through what's essentially an audit program for you. And this is going to be fairly long, and you'll probably forget half of it before we're done, but we do have the slides available online, and you can actually just print these out and use them and adapt them to your own environment. So first off, as we would do with any other data center, we want to consider the physical and environmental security of your host servers. So this entails fire suppression, air conditioning, humidity control, flooding protection, so raised flooring or water sensors. You also want to have the servers themselves raised onto shelves or racks, protected and locked. Think about who has access to these servers, access to the server room. The actual personnel should be highly restricted. Not many people outside of a few IT personnel would need to go in there. Another thing that you want to consider that's actually specific to virtual and host servers as opposed to a traditional configuration is the issue of backup power. If a host server shuts down unexpectedly, all of the virtual servers on it also crash. So if power gets cut, you want to make sure that you have uninterruptible power supplies on your host servers, and be careful that you get enough time from them to A, support the larger hardware that's probably involved with a host server as opposed to a traditional server. And also keep in mind, the virtual servers that exist on that host server all need to shut themselves down gracefully before the host server can begin a shutdown. Or else, even if you gracefully shut down the host server, all the virtual servers that existed on it will shut down unexpectedly. There are a few workarounds for that, but what you really want to make sure is that your shutdown procedures involve every virtual server goes down first, and then the host server goes down. So make sure you have enough backup power supply to give yourself time for that. Aside from that, there aren't any really specific controls in terms of physical and environmental security that you want to be aware of for a host server as opposed to a traditional server. Some hardware specifications on the server itself, though. These are, again, there's reduced fault tolerance here, so you want to make sure that you can account for the usage that these servers are going to get. So you want to make sure that the host has a great deal of memory, more than a traditional server would have, and that you can support extra memory for future expansion. As a root, it's going to vary depending on your usage and the number of virtual servers that exist on it, but 128 gigs of memory is great. Look for that, with room for expansion if you can. Again, you want to look for top-of-the-line processors in place, quad-core. And once you have all this in place, as a general rule of thumb, you're just going to spec it to your vendor's requirements from the virtualization provider and the applications running on it. But give yourself a self-check after that's done. Take a look at the memory and CPU utilization, and disk space utilization too. Memory and CPU utilization should generally stay around 1/2 of capacity, not a lot greater than that. Now, it does get shared out efficiently, so it doesn't need to be spec'd for peak usage the way a traditional server would, but you still don't want to cut it too close. Give yourself some slack in terms of the hardware capacity and bandwidth. These servers are pretty powerful. They need a lot of cooling, so make sure that you have sufficient cooling systems in place, that is fans. Not just sufficient, but redundant if you can. If one fails, make sure that another one is there to keep it from overheating. Another issue is network interface cards. Many of you have probably dealt with these in the past. They tend to fail, just the hardware on them. You want to have at least 2 network interface cards for the virtual servers, if not 1 interface card for each server. And in some cases, you want to have additional network interface cards beyond that. For example, we recommend having 1 dedicated just to the management interface. And again, just follow your vendor specifications, but don't cut it too close to the maximum bandwidth. Okay, some technical network security controls. You want to make sure that all of the standard sort of administrative management controls that you have over your network also extend to the host servers themselves. This is where we often see a lot of exceptions. An organization might have a great patch management system, but you have to remember, even though it may be a Linux ESX server, even those receive patches and updates occasionally. How are you monitoring for those? Make sure that those get updated. If you're using Windows in particular, make sure that you have an antivirus solution in place for it. Event log management. Again, we tend to see this drop off when you look at the host servers. There's usually a strong event log management in place for the network as a whole, but it doesn't necessarily cover the host servers. Make sure that it does. In an ESX environment, that would be under the root var log directory and subdirectories under that. So you want to make sure that sensitive actions are being recorded to that log directory. And if you're using a Windows server with Hyper-V, just make sure that you have audit policies configured to record sensitive events and event logs that will capture and report on those for you. Ideally, you want to actually have a host firewall on the host server itself, a client-based firewall. This would be in addition to your network perimeter firewall device. Have something that's either a host-based firewall installed, software firewall on the host, or even another physical firewall device further segregating the host from the rest of the network. Again, these are the keys to the kingdom. You really want to protect them. Another thing that you should do with a virtualized environment is to segregate the management interface from the rest of the network. This is a best practice that we tend to recommend. So we want to have one NIC on the host server that's dedicated to just the management interface, the virtualization application, be it VMware or Hyper-V. Anytime you need to actually log in and access that, it should happen through one dedicated NIC, so one network segment, or even a particular workstation that you have to physically go to and log in. It may be a bit overkill for some environments, but the other option would be to have a VPN system where you have to VPN to a separate network segment and then access the management interface from there. Okay. Next is user access controls. This is another area where you probably have strong procedures in place to cover the network as a whole, but how do those extend onto the host servers? You want to make sure that you have authorization processes. So that's probably going to happen very rarely. Not many people should have access to either the server operating system or the management console. But you do want to have authorization procedures in place. You want to have unique user IDs. Don't just go with the built-in administrative user IDs, either on the operating system or on the hypervisor application. Assign one ID to each user. One, because it's easier to manage that way. When someone leaves, all you need to do is disable that account. When someone comes, you just need to create a new account for them. And also because it provides what we call non-repudiation, meaning if something happened under one person's account, they can't claim that someone else was using the administrative account at that time. You want to implement user access restrictions, particularly for the root account in an ESX environment or the administrator account in a Windows environment. These should not be used under normal circumstances. Again, you want to have every individual user, within a person, having their own user ID. If something absolutely needs to be done under the root or administrator account, then you should either use the run as commands in a Windows Server environment or the sudo command in a Linux environment. Don't allow the switch user command. So don't root the server, just sudo the server instead. Also limit knowledge of passwords to those two accounts. Obviously, that should go without saying. Only a very select number of people should know those passwords. Lastly, you don't want to allow remote access to those accounts if you can help it. Remote access should be allowed for people using their own individual accounts, and the root and administrator account should be either using the run as commands or physically going to the workstation in order to use them. Okay, moving on, authentication. What type of authentication mechanisms do you have in place? Before you even reach the operating system, I mentioned you could have a VPN solution in place to reach the management interface. Once you're there, you're going to have to log into the operating system of the server, the host server. So what types of passwords you have there, lockout parameters. And also you need to log into the virtualization management console. These might be served as a web page that you could log into as long as you're going over the correct interface. But you still want to make sure that you're applying administrative controls to both the operating system and the hypervisor application. Make sure that you're restricting, as much as possible, who can do sensitive actions on those applications, who's allowed to shut down or restart a server. Hopefully not that many people. And if possible, implement an administrative activity monitoring process here. So periodically review who has access or what access rights have changed, and if they've done anything suspicious, if your system supports that type of reporting. Moving on, business continuity. So I've mentioned how business continuity is aided greatly by implementing a virtualized infrastructure, but you want to make sure that you've also accounted for the host servers themselves, the virtualization infrastructure itself in your business continuity plans. So if you have a Hyper-V system set up, make sure that you're using Microsoft Server clustering, if at all possible. Similar, if you're using an ESX VMware setup, you want to use vMotion or some equivalent high availability configuration. If that's not possible and not cost effective, then at least make sure that you have a redundant host server available. And by this I mean the actual hardware. It's not that easy to just order a replacement for one of these host machines and have it in at the end of the day. So if you can have a backup ready to go at a disaster recovery facility, make sure that you do that. and make sure that all of your virtual disks are replicated to that disaster recovery facility so that the current version of each virtual server can be loaded into that redundant host server. Don't just rely on backing up the VMDK file itself. That's the actual virtual server file. So if you have a copy of that, that's great, and you can reload the server into a hypervisor application fairly easily. But it doesn't allow you to very easily recover, say, an individual file that someone may have deleted accidentally. So you want to make sure that you have a traditional backup system in place as well for your virtual servers, and that those backups are taken either to an off-site facility if they're hard copy, or replicated to an off-site SAN or other system like that. And lastly, you want to test the restoration of these virtual servers. So when you actually go through the process, make sure that they're not just available as a VMDK file at your DR facility, but make sure that everyone knows how to load it into the hypervisor application, how to get it up and running, how to get the applications that run on those virtual servers up and running, and the most recent data loaded into them. So when you do your VCP testing, actually follow it through to the end, usable data in applications. So beyond that, there's some virtualization-specific controls, as I call them, that really would not apply to a non-virtualized infrastructure. So these are some very specific things that you want to look for in your virtual environment. First of all, the virtualization software, whether it's VMware or Hyper-V, make sure that it's the most recent version available, or at least it's the most recent patch of the version that you're using. And beyond that, make sure that you do have a current and valid support contract. So you don't want to be hung up to dry if something goes wrong. Each individual virtual server should have disk space partitioned for it. I mentioned availability concerns when you're using one host server. If, for example, you had an email server, virtual server running on one host server, and you didn't have email size restrictions on people's mailboxes, they could theoretically fill that up pretty quickly, the entire disk space for your host server. And then none of the other servers that run on that host would be able to allocate any disk space to themselves. They would essentially denial of service the entire host. So you want to make sure that you're partitioning out the necessary amount of disk space for virtual servers with some slack. Similarly, enable resource reservation in terms of memory and CPU usage that goes to each individual virtual server. These are things that can be done from any hypervisor application. I touched on this before, but try to restrict the remote management access to specified workstations, if at all possible. So not just anyone can log in and try to guess the password, try and brute force their way into the management console. That really is the keys to the kingdom. When you do management, utilize the actual GUI console that's provided with it. Don't try to do everything by a command line interface. That just makes things very difficult, and it's prone to errors, no matter how good you are. So you really should only be accessing the host server's operating system or any CLI interface when absolutely necessary, which is rare. The other aspect of that is the virtual management consoles have generally better logging and access control than you would get just on the OS itself. On every NIC that you have installed on every host, disable the promiscuous mode. That's just something that is a best practice for most servers, but especially important here. And a few more here. Automatic startup should be enabled on most of your virtual servers. This will be situation dependent, but if a host server restarts, without this option, you would need to go in and manually start up each virtual server. Again, that's a process that could be error prone. You might forget one, or you might forget some services that need to start up, and people will wonder where they are. So I recommend automatic startup in most situations for virtual servers. When you do this, assuming that you're in an Active Directory environment, make sure that you start the domain controllers first. The management application should allow you to specify the order that they're started. Domain controllers need to go first so that everything else is able to log in with their domain credentials. If you're using an ESX environment, disable remote root access. Again, I mentioned that one. You should switch user for any type of thing that needs actual root credentials. Also for ESX, you should be using ESXi, which is a lightweight version. Version 5.0 is the latest, or well, is the baseline that we usually look for. You may be on an older one, but if so, you should look towards upgrading to ESXi version 5.0. VMware application itself on the hypervisor. Two options here are forged transmit and MAC address spoofing. Both of those options should be set to reject. That can prevent a man-in-the-middle attack within your own network. And if you're using a Hyper-V situation, you should be using Windows Server Core 2008, which is a little-known distribution. It's a version of Windows Server 2008 that is it's very pared down to only the basics needed to operate the server. It's mostly CLI-based. It doesn't have many of the same services, and it just has a much smaller footprint, which has two bonuses. One, it reduces the amount of system resources that are needed to run the OS itself, and it also shrinks the footprint that an attacker could use against the OS itself. Okay, as I mentioned, if you want to get all these bullet points, they will be available in the slides that will be online. But that's it for virtualization. Imagine there'll be some questions that we'll take at the end of the presentation. So now we'll move on to cloud computing and go through this one a bit more quickly. So first of all, what is cloud computing? Well, similar to virtualization, it's a method by which computing resources are centralized and shared by one provider. In this case, it goes over the internet. Again, we're talking about that same concept of infrastructure convergence, where the resources go where they need to be at any point in time. But this is taking a completely different tack. Whereas virtualization is more of an inside-out infrastructure convergence, this is outside in. We're going to an internet-based provider rather than creating the situation ourselves. In general, what we see here is the end users receiving the computing product as a service. There's no need for local infrastructure or much reduced need for any local hardware infrastructure. We're actually pretty familiar with these, as we'll see. It's infrastructure as a service, platform as a service, and the one that we all know and love, software as a service. Those are the three deployments, or the three layers that we generally see with cloud computing. Now, software as a service, I think we're all familiar with. The others are the infrastructure and platform layers that are defined in the standards. So infrastructure as a service would be the hardware itself being served out where it needs to go. So virtualization is sort of like an infrastructure or platform where the actual computing resources, the memory, the disk space, goes where it needs to go. When we see it as a cloud computing layout, what this tends to be is something like a WAN that has a cloud-based infrastructure, whether it's like a frame relay network, an old frame relay network, or a newer MPLS network. Those are actually infrastructure as a service that's being provided to you. On your network diagram, it's represented as a cloud. Platform as a service is when you buy something like a, say, development suite, but you don't actually own and maintain it, but you create the systems and the applications that operate on it. SharePoint services sometimes fall on a platform as a service. And then software as a service is usually the hardware and the guts of it are completely transparent to the end user. All you see is the final product. Now, these can be deployed in numerous ways: public, community, and private. Usually what we see is a public deployment model, which would be some vendor selling their product across the internet to whoever needs it. And from your perspective, it ends up looking private, but really it's anyone who wants to buy the service is going to be sharing that infrastructure. Community would be something like a municipality, and a private cloud implementation is usually for huge corporations with global operations who create their own cloud. A hybrid would be any combination of those three deployment models that intersect with each other in some way. Okay. But to actually talk about it in more practical terms, what do we actually see when we're talking about cloud computing? Like I said, we're pretty familiar with this. Maybe the term has become a new fad, but we've been seeing this for a long time. VPN setups are infrastructure as a service. Frame relays, MPLS, infrastructure as a service. We're all familiar with core banking service providers, where you don't need to have the mainframe on site, you just have the application that you link back. There are a number of other hosted financial applications. We've seen those for a long time, and we're quite familiar with them. The reason that we're hearing so much about the cloud lately is really because of some of the new concepts that are being offered that are appealing more towards end users and consumers, and it's on our mind more. But they have business applications as well. Some of the things that we're starting to see now with varying frequency would be email services offered as cloud services. document management, backup, and data storage situations, Carbonite, and all of those. Even office productivity applications are starting to be served as SaaS systems. So you don't need to have, for example, Microsoft Office and Word and Excel installed locally on every PC. Webinar and remote access systems are commonly being offered as cloud services. The system that we're on right now is a cloud webinar system. Okay? So it's not all that new. We're just hearing more about it lately, I think. But there are some new applications that are being proliferated lately. So we have to think about how that's going to impact our environments, whether it's the old systems that we're familiar with or new systems that we're looking at implementing. There's a lot of benefits to cloud computing, just as there were for virtualization. You may be talking about major cost savings depending on the scope and the scale of your operations. What we're really dealing with here is operating expenses versus capital expenses issue. If you have to buy a lot of hardware and install it in-house, that's a lot of upfront cost. Whereas sometimes it's easier just to sign the check every month and not have to worry about much of an initial setup. In this case, though, the cost proposition varies greatly. I can't really say that going to a cloud environment will definitely save any of you money on any situation. There are a lot of situations where it definitely could provide cost savings to varying degrees, but this one is not, it's much more variable than the virtualization environment was. It tends to scale pretty well, but again, you have to hit the sweet spot in this case between operating expenses and capital expenses. What's definitely much easier about a cloud system here is the ease of implementation for a system. Usually it's as simple as signing up for a service, having some type of an initial setup where they provide you with credentials and upfront training, and then you're good to go. You sign the check every month and the system is made available to you. You don't need to install servers. You don't need to install the applications on those servers or any type of gateway hardware. It's all provided to you. It just comes over the internet. As a result of that, you tend to need less in-house expertise. This is great for IT departments who already have 101 things to worry about. You don't necessarily need to become an expert on this one other application that you want to install. You really just need to know how to use it from an end-user perspective and how to manage the vendor relationship. On the same note there, you're assuming that the service provider hopefully has a lot more focus and expertise on this area than you might in-house. They build themselves to be experts in whatever service it is they're providing to you. It's what they do day in and day out, whereas it might be 5% of your operation. So hopefully, they're going to keep it up to date with the latest technologies, with the latest updates, with the latest regulatory updates. It should stay up to date with that, and you don't need to worry about it. The service provider will do that for you. I mentioned that you don't need hardware and software in-house in most cases. And as far as business continuity goes, as long as you can rely on that vendor, that servicer being available to you, all you need is an internet connection to get to it. So you don't even need server backups and application backups. You just need to move to a different site, connect to the internet. They may have other systems in place. They may need tokens installed on your computer or other security methods. But generally, it's much easier to account for business continuity in a SaaS environment than it would be hosting all the systems in-house. It's not to say there are no risks with a cloud-based environment, obviously. There are several types of risks that people look at. Some of these may be just fear, and some of them may be well-grounded in reality. We're going to go through some of them. The first major area is privacy, and this is a big one. In any SaaS system that you're getting, or infrastructure as a service, it's going to have what we call multi-tenancy. There's going to be, every customer is probably going to be sharing servers or sharing routers or sharing some type of hardware there with other customers of that provider. So that means my data is going to be in some way, shape, or form mixed in with someone else's data somewhere along the way, whether it's crossing the same router, whether it's being in the same database instance. It varies, obviously, depending on what we're talking about here, but there is a multi-tenancy concern. So I need to be comfortable that another client logging into their instance won't be able to see my data at any time, whether intentional by poor design or by accident or by some type of exception. Another privacy issue is that the service provider is going to have access to all of the systems and all of the data that exists on those systems in some way, shape, or form. If they host the servers, if they host the application, if they update it, then they'll be able to see it one way or another. Now, You may have contract language, you may have assurances, you may have encrypted data, but it's highly likely that someone at that service provider organization would be able to see your data, even if it's a rogue employee of theirs who's going completely outside of their technical controls. So that, hopefully there are controls in place to prevent that, but that's a concern to be aware of. It is a risk of cloud-based infrastructure. Security on a more technical level is another risk. What about data encryption? That's become a huge deal lately, data encryption. And we're talking about data in transit, which you would assume is in place, particularly with the SaaS solution, at least SSL with some strong encryption, hopefully something even better than that. But also, what about data at rest? If it's installed on a database there, are you sure that no one can see it and read it in clear text? So you've got to be very concerned with data encryption when it's leaving your own internal environment. You're going to rely on the vendor-provided user access controls. So in this case, I'm not talking about access controls on their end. I'm talking about access controls on the system that they provide to you. If all they give you is a blanket user account and you can't configure specific user access rights on it, you can't have an administrator at your organization and just an end user at your organization, and just a read-only auditor at your organization, that might be a concern. And there's not always anything that you can do about it. So sometimes you just need to take what they give you and hope that it's good enough to meet your security needs. On the flip side of that, you also have to rely on the controls they have in place at the service provider. What types of physical security do they have over the servers or the data? What types of logical security do they have in place to prevent people from breaking into the systems? What are their business continuity concerns? I mentioned that business continuity is simpler from your perspective because you only need an internet connection. But all the internet connections in the world aren't going to help you if the service provider blows up and they don't have a backup plan. So you need to be aware of that. And lastly, processing integrity, making sure that what they're doing, particularly for transactions, they're maintaining the integrity of any transaction that flows through their system and can guarantee it to you. And the availability of system logs for monitoring and review. You probably want to have, depending on the criticality of the system, some type of a periodic review process in place to make sure that nothing suspicious or malicious is happening within these systems. So you need to make sure that they have available to you some type of logs to review in order to assure that. It's not always the case. Just with the access controls, they may just not make it available to you, and you have to press for it. So a few other risks to be concerned with here. What about compliance risk? Does the cloud service provider comply with your own regulatory requirements? Now, if it's a provider that specializes in financial institutions, hopefully they do. But you need to be assured of that. The two that come to mind immediately are the Mass Privacy Law and the Gramm-Leach-Bliley Act. Now, those are pretty specific and pretty tough regulations, and both of them require you to make sure that your service providers are also in compliance with them if they're getting customer data. So you need to be able to do that. And will they allow you to have contractual non-disclosure agreements, contractual service level agreements, and other requirements of that nature, so that if they start to slack or slip, that you can actually hold them to the fire for it. And business continuity, again, I touched on that. You want to make sure that you can connect to them from your main site, make sure that you can connect to them from your backup site. Make sure that they have their own business continuity plans in case their main site goes down. They can relocate to a backup site, and you can then connect to that backup site. So those are all risks that are introduced by using a SaaS system. What it all boils down to is vendor management. There's nothing particularly new about this. It's making sure that you follow the strict, stringent, and yes, they can be a pain, vendor management controls for critical vendors. Apply them to any cloud-based provider. So what's that going to entail? There's a few sort of aspects of vendor management that we'll go through here. First, everything should be, and this is the auditor and me speaking, documented, and it should be included in a formalized vendor management program. So you want to lay out everything that needs to be done and everything, document everything that you do in accordance with that program. It should be fairly robust. So assuming that you have all that documentation stating what is to be done, what should that actually include? What's going to be in your vendor management program? Well, first of all, a vendor risk assessment. This has been a major issue with regulators, and particularly the Gramm-Leach-Bliley Act examinations over the past several years. You have to have a vendor risk assessment where you're identifying your critical vendors. And critical can mean a few things. It can mean that it's critical to your day-to-day operations. It can mean that it's critical because of the risk that it presents to you because of the information that you're giving them. It can be critical because of monetary risk, because they're processing transactions. And another key here is anytime you're actually giving customer data to the vendor, you need to note that in your risk assessment as well. So once you've done that, identify what are the critical vendors. Do a quick hit of the controls that you have in place of them, at a minimum, to mitigate those risks. The vendor management, risk assessment process essentially works as an identification and inventory of all your vendors, the assessment of the inherent risk for each vendor, the assessment of the threats that go along with those risks, and your controls to mitigate those threats. So those are the steps of a vendor risk assessment that you need to have. Once you've gotten that far, though, you can actually use that to your advantage to reduce some of the vendor management overhead, the administrative headache that goes along with it. Because you have a justification now. With a completed vendor risk assessment, you have a justification for focusing your efforts on the critical areas where they matter. So only high-risk vendors will need to have the full suite of due diligence activities performed, whereas low-risk vendors can have just the most critical, most basic review activities performed. So doing an initial risk assessment is painful, yes, but you can realize efficiencies going forward in future years once it's in place. Okay, the next aspect of a vendor management program is the selection due diligence. Selection due diligence means that this should happen before you've even picked a vendor, before you've finalized and signed a contract with a vendor. So too often what we see happen is that one particular department within an institution will decide they want something and a contract is signed, and then it's thrown onto the lap of the risk department or the IT department to secure this. Really, you want to make sure that the security due diligence review is inherent to the actual selection process before anything gets signed. And some things that would generally be included in those due diligence reviews would be the financial condition of the vendor, if they're critical to your operation, to make sure that they don't go belly up and disappear tomorrow. You want to review the qualifications, experience, and capabilities of the vendor, obviously, to make sure that they can meet your needs. An important one here is the internal controls and audit reports to make sure that their end is up to the same security standards that you would expect within your own environment. You're probably familiar with SAS 70 reports. Those are gone now. What we have in place for that is the SAS 16 report, which actually breaks down into 3 categories, a SOC 1, a SOC 2, or a SOC 3 report. Those will spell out the controls that are in place on that vendor's internal operations to protect your data. You want to get their business continuity plans if possible to make sure that they have them, first of all, and that they're adequate in order to continue your operations in the event that they have an issue. Review their reputation, make sure that their user groups aren't panning them on a weekly basis, and see if they're going to outsource any of these operations to subcontractors or third parties. They may not be particularly forthcoming about that, but depending on the type of activity that you're going to be outsourcing to them, you want to try and get that information if possible. And when you go through all of this, document everything, because examiners and auditors will look for it. Okay, next is contract requirements specific to cloud services. So you should have, as part of your vendor management program, general contract bullet points that you want to see in every contract, depending on what type of services they're providing to you and the criticality of this vendor. But some ones that you want to be particularly aware of, if this is a SaaS provider or an infrastructure provider, is data privacy. Make sure that they have a clause in their contract requiring them to comply with GLBA or mass privacy or any other type of compliance requirements. Service level agreements, if you can get them in there, do it. You want to have uptime, you want to have response time for issues. Those will only benefit you. Reporting and the right to audit, same thing here. See if you can get those types of reviews sent to you to make sure that you can see what's going on. Whether it's an annual basis or a quarterly basis, to review those types of reports and make sure that nothing suspicious has occurred. Who actually owns the data? Usually contracts will include something along the lines of application ownership and intellectual property ownership. That should also include the data that's stored on those applications, what they can do with it, who can see it, and as I mentioned, other standard contract elements that you'd want to see. Lastly here, you want to have, as part of your vendor management program, an ongoing monitoring and assessment piece here. This means you don't just look at them once when you're getting them, but you continue to look at them on a periodic basis based on your vendor risk assessment. So you want to get, during these monitoring processes, a review of vendor access to data. Again, this is something that may not always be available, but if at all possible, push them for this. See if there's any report that could show you if vendor personnel access data that you should be controlling and protecting. That report may exist, it may not, but if possible, get that. An annual review of their internal controls audit report, as I mentioned, the SAE-16 or SOC 2 report, you want to get that every time it's released in a timely basis and actually review it. I think the SAE-16 and the SOC 2 are better standards than the SAS 70 was, and they'll be a little bit more clear to the reviewer. So hopefully that helps in your review process going forward. One thing that you want to make sure that you include in this process is a response to the user control considerations. These have actually been renamed as complementary user entity controls, but it's the exact same thing. It's a level of security that the vendor can't guarantee based purely on their controls, so things that you need to implement on your end to guarantee security. So make sure you review those and implemented them. If you can get them, get the vulnerability test results, particularly for a web-based solution. The business continuity plans, if you can get them, get those and review them. And just as you did up front, continue to review their financial condition, continue to review their reputation or any kind of actions pending against them, and if applicable, review their performance related to any type of service level agreements that you had in place. Again, document everything. People will ask for these types of activities. Okay, so that does it for the first pass through. I imagine there are probably some questions. So I'll turn it over to Ashley.
Thanks so much, Ryan. We do have a few questions. So continue to send them in, because even if we don't get to all the questions right now, Ryan can definitely follow up with you after the webinar is over. So to start, Ryan, can virtualization help to increase the efficiency of business continuity efforts over safety deposit boxes?
I don't think it would apply to safety deposit boxes. You're talking about physical items there. So you will need to have business continuity plans in place for those. But for any electronic data, then yes, this could definitely improve the efficiency of your operation.
Great. Thank you. All right, we have our next question. Why is it important to have a tape backup for virtual servers? Is it necessary to duplicate this process?
So what you don't need is a duplication of an online backup system. Tapes aren't required, but what I was referring to earlier was you don't want to have just a backup of the VMDK file itself and rely on that. You want to have whatever your existing backup solution is, as if it were a regular server, to still have that in place for the virtual servers. That would be in addition to having the VMDK files available to be restored in a disaster situation in your DR facility's host server. Another aspect that you want to consider here is that the granular file, and I mentioned this before, the granular restore, so if someone, for example, forgot, they deleted a file and forgot about it, they want to go back and recover it from yesterday, that wouldn't be very easy to do if you only had the VMDK files. One other element here is don't just rely on having a mirror process in place. So if you're replicating to a disaster recovery site in real time, again, with the deleted file or need to back up to yesterday's data, you want to make sure that you have an archive in place as well, something to go back to. So if that's a tape process, then fine. If it's an electronic vaulting process, then that would also work.
Great. All right. When you say that corporations will not need expert staff to take care of the servers, Do you mean only if everything's outsourced and no hardware is local?
Yep, so in a cloud-based environment, if they have local hardware that needs to be installed within your application, if it's, for example, a gateway router of some kind or middleware perhaps, then you probably would need at least a minimum level of expertise in-house in order to maintain that hardware. But even in those cases, the cloud vendor will usually provide a level of support to take care of those devices. In many cases, they're going to be just black boxes to you as an institution. You won't even really know what's going on inside them. They're just going to sit there somewhere in your environment, physically sit there, but the vendor will take care of them. And that's in most cases. Again, obviously it's going to vary from one cloud provider to another, but usually you won't need much in-house expertise in order to manage the systems, other than the end-user aspect of it. As opposed to virtualization, where in that case you will need a great deal of in-house expertise to manage the ESX servers in particular. Linux is much more difficult to operate than a Windows environment, obviously. So if you plan on taking care of those ESX servers in-house, that may become an issue for you. Usually they're going to have support staff available to you, whoever you're buying from. If it's a VMware setup, you're going to go through a provider who will help you with the more high-tech aspects of an ESX implementation. But again, where it's a Linux box sitting on your environment, that may create another level of complexity that you need to be able to handle.
All right, and our last question for today. Given a COBIT environment combined with ISACA controls, what method of authentication would you recommend in a virtual environment?
Okay, so it depends on where we're talking about the authentication. If we're talking about authenticating to an application, then it's going to depend on the specific application. What is the risk of that application? Usually just standard username and password controls are still acceptable, even by the FDIC standard, for internal applications. So just logging into an application that exists purely within your own environment, just username and password is fine. When we're talking about authentication to the host server or to the hypervisor application, it gets a little bit more interesting there. So authentication on the host server's operating system. Sometimes what we see here, as I mentioned, is that you tend to fall back to that the kind of IT department standard of it comes with an administrator account and that's what we're going to use. We don't want to do that, even for a host system that's rarely going to be accessed. You still want to have unique user IDs and individual authentication. And the passwords that you have in place should be up to your institution standards. So it should be, if it's 8 characters, then it should require 8 characters for every user. If it's expiration, then you should require expiration as well, and lockout controls. So have those all in place. Same thing, have those same types of authentication controls in place for the application in addition to the operating system. To access it, as I mentioned, you want to go through the application whenever possible, which is usually an SSL-secured web, or not web-based, but browser-based system. At least for VMware, that's what it tends to be. So you should be going through the vCenter application. And make sure that you're using HTTPS. So that would be SSL, username and password authentication. Don't just remote into the server, especially using something like Telnet or whatever. If you're going to use the CLI or log into the operating system itself, then you should at least be using SSH. But again, you shouldn't be logging directly into the operating system very often at all. Try to go through the secure authentication that's built into your hypervisor application. So generally, we're just looking at standard SSL here. And because it's internal, you won't need to worry about going over the web and managing certificates, but do have that security in place. One last authentication option here. I talked about how you can have a separate, how you should actually have a separate management interface for accessing that hypervisor application. If you're going to set it up that way, then you can have a separate firewall segment, almost like a DMZ for that hypervisor interface. In that case, you can VPN to it, and if you really wanted to implement an extra layer of security, you could put multi-factor authentication systems in place on that VPN connection, like an RSA secure ID token. That would be the last layer of authentication that could be present here.
Great. Well, our time's up. Thanks so much, Ryan. A lot of great information here. As a reminder to our audience, you can download Ryan's presentation slides at www.wolfandco.com/webinars/2012, and I'll be posting a recording of this presentation to the same web address later on this afternoon. So feel free to access the slides and recording after the webinar is over. Upon conclusion of this webinar, you will have the opportunity to complete a survey. And as always, we appreciate your feedback so we can continue to improve our webinar program. Thanks so much, everyone, for attending today. Thank you, Ryan, for presenting today. And we look forward to your participation in future webinars. Have a great afternoon, everyone.